Lesson. Describe how paper chromatography is used to separate mixtures of soluble substances using a suitable solvent. Describe the use of locating agents when separating mixtures containing colorless substances. Knowledge of specific locating agents is not required. Here's a summary of the last lesson. Simple distillation is used to separate a pure liquid from solution. Miscible liquids are those liquids which mixes or dissolves in each other. Fractional distillation is used to separate a mixture of miscible liquids. Theory or separation is based on the difference in the boiling points of different liquids. What is chromatography? It is made up of two Latin words, chroma and graphy. Chroma means color. Graphy means writing. In earlier times, this technique is used to identify colorful substances like dyes, pigments, food colors, but nowadays colorless substances like amino acids can also be identified. The technique relies on the relative solubility or attraction of the individual components either for the solvent or chromatography paper. Let me write technique relies on the solubility or attraction either for the solvent or chromatography paper. What is paper chromatography? Here chromatography paper is used. Chromatography paper is used. Dye is introduced from the bottom of the paper. The solvent is soaked up the paper. Solute present in the dye will get dissolved in the solvent to different extent because of different solubility. That is, some are more soluble, others are less. In other words, solutes which are more soluble in the solvent will travel or cover long distance on the chromatography paper, and those which are less soluble will travel less. Solutes which are more soluble in the solvent will cover large distance. While the solute which are less soluble will travel less or will cover less distance. Thus, the difference in solubility allows the different pigments in the dye to be separated. The other term used for solvent is mobile phase and stationary phase instead of chromatography paper. Solvent, you can call it mobile phase. In the same way, chromatography paper, stationary phase.
Welcome to Chain of Qualified Tutors. Unlock your academic potential with expert tutoring. from secondary school to graduation level. Master math, science, English, and more with personalized one-on-one guidance. Call or WhatsApp for a free demo session. We offer on-site and online tuition.
This is a chromatogram obtained for two different mixture of colors, that is X and Y. Start line, which is also known as baseline, is drawn with a pencil. This is the start line, also known as baseline. Remember, you can't use pen or pointer because the dyes present in the pen get dissolved in the solvent and travel along the chromatogram. And this will ruin your chromatogram for the colors you are going to identify. Use pencil, not pen. Why locating agents is used in chromatography? Locating agents are used to identify colorless substances. For example, amino acids are colorless, but can be identified with this technique. The only thing that is required is locating agent. Let me write locating agents are used to identify colorless substances like amino acids. Locating agents react with the colorless substance to produce colored stains. For instance, ninhydrin. Ninhydrin is a purple color which reacts with amino acid to produce purple stains, and thus amino acids can be identified through this technique. Read simple chromatograms to identify unknown substances by comparison with known substances. Pure and impure substance. State and use the equation for RF. RF is equal to distance traveled by the substance divided by distance traveled by the solvent. Here's a summary of the last lesson. Chromatography is used to identify colored substances like dyes, pigments, flavors, etc. Chromatography relies on the relative solubilities attraction of the components in the or for the solvent or chromatography paper. In chromatography, colorless substances need locating agents. In this lesson, I will teach you how you're going to interpret a simple chromatogram to identify unknown substances by comparison with known substances as well as pure and impure substance. Consider the following chromatogram to identify the presence of L, M, N, and P colors in the mixtures X and Y. You can see Y contains L and P only, as it is revealing only red and brown spots. This is the red spot and brown spot. So it contains L and P. Can you identify colors present in X? Here's a hint. X contains yellow, red, and purple or violet spots on the chromatogram. Which means it must contain N, P, and M. Now let's talk about RF. RF is the retention factor. RF retention factor. You see this diagram showing chromatogram obtained by analysis of a single dye. This line is the original level of solvent. Original level of solvent, also known as baseline. Here is the original spot of dye. Original spot of dye and final position of dye. Final position. This is the final position of dye. Y is the distance traveled by the dye. Distance traveled by the dye. X plus Y is the distance traveled by the solvent in the same time. X plus Y is X plus Y. Distance traveled by the solvent in the same time. How is the RF value of the dye calculated? We use this formula. RF is equal to distance traveled by substance divided by distance traveled by solvent. Therefore, RF or retention factor for this chromatogram can be calculated as Y divided by X plus Y. You can easily calculate. There won't be any unit for RF value obtained.